All right, I've got a simple little circuit put together here. I've already built it. If you want to build this one yourself, you want to go back to Lab 1, and Lab 1 walks you through how to build a simple circuit like this. I've got a couple of voltage sources, batteries here, equivalent of batteries. These are DC supplies. Okay, they're connected in series. If you look, they're connected. The top terminal is the positive terminal for both of these 5-volt battery sources, okay? Then I got a 1K ohm resistor in series with the 2K ohm resistor, in series with the 3K ohm resistor, in series with the 4K ohm resistor. And we've got ground sitting right here. And what that means, what the ground means, we talked about this a little bit in Lab 1, means every voltage that we measure is going to be with reference to 0 volts. So if you had a DC voltmeter, you would connect the black lead to this point right here, the ground point right here. Then you would take the red lead and go in and probe each of these points if you wanted to measure voltages at each of these nodes. Everything is connected in series. Current, there's only going to be one current, and it's going to flow from the positive terminal of the battery, if we're using conventional current flow, to the negative terminal of the battery. And again, notice both batteries are oriented in the same direction. Because these two batteries are in series, you can combine them into one equivalent 10-volt source. Because these resistors are all in series, you could combine all 4 of these resistors into one equivalent resistance. If we were to do that, we'd have what? 5 plus 5 is 10, so we'd have 10 volts in series with 1 plus 2 plus 3 plus 4. That's 10 k ohms. Okay, so 10 volts in series with 10 k ohms. We could use Ohm's law to calculate the current. It's just V divided by R. So it'd be 10 divided by 10K. Or we should get 1 milliamp when we start measuring this thing. Excuse me. All right, so let's do the PSpice analysis now on this. All right, so we have to go up here and we have to select the simulator, okay? So I'm going to go here, okay? So we want to create a new simulation. I'm going to call this, I'll just call it Lab 2. I'm going to say create. Okay, just like we did in Lab 1, we're going to want to go with the default simulation settings. So we're going to do a time domain transient analysis, and we're going to stick with general settings. I could click apply and OK. If you just click OK, it does both actually. All right, so there's our circuit, and since we ran that, we set up the new simulation profile that we called Lab 2. Now this little green button lights up here, up on top on the ribbon, and we're going to run PSpice now. So I'm going to run it. And when I run it, I'm going to watch down here. I'm going to watch my logs. And if you get any error messages, that's where these things are going to pop up. So here, what have I got? I've got PSpice netlist generation complete. It looks like it ran okay. Okay. And also notice now the V, the I, and the W buttons have lit up after we ran the simulation. So if I click V here, I'll see all my voltages. Let's click it again. There we go. Okay. I'm going to turn current off. Let's just look at voltage now. So we're seeing all our voltages here. These are all our node voltages. So if we were to take a meter, again, a DC voltmeter, attach the black lead here and go in and probe each of these nodes, these are the voltages that we would measure. Okay? Makes sense, right? We got 0. We got 5 volts here. So as we go around in a clockwise direction, 0 plus 5 is 5, plus another 5 is 10. So both of these components are sources, so we're going to be supplying voltage. And each of these resistors is going to actually drop voltage. So if I'm measuring 10 volts here on this side of R1, and I'm measuring 9 volts here on the other side, I'm dropping 1 volt across this 1K ohm resistor. Same thing here, 9 minus 7 is 2. 2 volts dropped across R2. Okay, 7, 4. 7 minus 4 is 3. 3 volts divided by R3. You get the idea. And 4 volts divided by R4. I picked the resistor values and the voltage values on purpose here just to make it simple, so we could do the simple math in our heads. All right, so that's pretty cool. Let's take a look at current now. Here we go. There's only one current path, so all these currents should be equal, and they are. And if you remember the way PSpice indicates current, we're talking conventional current moving through a resistor from the positive to the negative side, the negative direction. So it indicates the positive side on the by starting the current value on that side. So here we know current is flowing through R1 from left to right because 1 milliamp. And PSpice starts it here, okay? Same thing through R2, 1 milliamp. PSpice starts it to the left. The text actually starts to the left of R2, okay? Through R3, it's going to go in the downward direction, right? It's going to flow from from here to here, top to bottom. And same thing through R4, it's going to flow top to bottom. And it's going to continue around the loop here. These two sources are, again, providing voltage and current. So, and we're going to see current flow through the sources in the upward direction. So we see the current start to be indicated at the below each of these sources. All right. So let's do a little. Let me turn these off. I'm going to make a quick change to this circuit. I'm going to flip both of these around. Okay, so I clicked on the V2 source, and I click R once, R twice. It's flipped. Okay, if you look here, my wire, I gotta put another wire in here. Oops. I gotta grab a wire here. I gotta put a wire from here to here. So we lost that wire connection. All right. I'm gonna flip this one too. I'm going to flip V1. So R. Just flip it around. Let's rewire this one now. Let's do this here. Rewire. User interface on PSpice is it's very windowy, I guess. If you're used to using a Mac, it'll take a little clicking around sometimes to figure things out, but you'll get it. All right, so now what do we got? We got the negative terminals at the top and the positive terminals at the bottom. If we use conventional current flow again, we know current flows from the positive terminal of the battery to the negative terminal of the battery. So what we've done by flipping these around is we've reversed the direction of current flow. At least that's what we should be. That's what we should be seeing when we run the analysis. Okay, we made some changes, which means we need to run another simulation profile, okay? So I'm going to click here. I'm going to call this simulation profile, I'll call it Lab 2. I'll just call it Lab 2B. And I'll say create. Okay. Again, time domain analysis, general settings are fine. Click OK again. Okay, the Run PSpice Lite, it comes up again. I'm going to click it. I'm not seeing any errors in the log here. The V's and the I's and the W's have all lit up. Let's click V. There's our voltages, okay? And again, everything was with reference to 0 volts. So if you look at what's going on, this gets a little confusing when you first learn it. We got 0 volts here on this side of the 5 volt, this V1 supply, but we're going from positive to negative. So we're gonna have a negative 5 volts here. Then we add another negative 5 volts here when we go through V2. We get a negative 10 volts here. And notice all the voltage drops here, because of where they're referenced, the reference to 0 volts here, or the reference to ground, are going to be negative. So again, with a multimeter, DC multimeter measuring voltage, black lead here, red leads at each of these locations. All right, let's take a look at current next. See what's going on with current? Look at it. Current's going to be going from bottom to top. It's going to be going in the upward direction through R4. Same thing with R3. Through R2, it's going to be going from right to left. Through R1, it's going to be going right to left. Through V2, it's going to be going top down, okay? And through V1, it's going to be top down. So that's pretty interesting, I think. You can see what happens when we start flipping things around. I'm going to get rid of these now. And there's one more little thing I want to do here. Maybe you've put one of the batteries in upside down in a 2-battery flashlight. Flashlight doesn't work. Why? Let's flip this one around. So highlight it, click R again. Okay, what do we got now? We got the positive terminal of V2 at the top, and we've got the negative terminal of V1 at the top. So these two batteries are equal and opposite in polarity. If they're each 5 volts, we should get a net of 0 volts. Okay, let's see what happens. We'll see if we get that. Now, once again, because I made changes, I have to go in and create another simulation profile in PSpice. It's just the way it works. So click here. I'm going to call this Lab 2C. Okay, you want to give each one a different name. Okay, I'm going to say create. Again, transient. Time domain transient analysis type, general settings, click OK. Okay, my run PSpice icon is lit up here. I'm going to click it. Watch my log. Looks like the generation was complete, no errors. I'm going to click V, and what happens? Very interesting. I got 0 volts everywhere in this circuit. Okay, and that's pretty interesting. Okay, and what are we seeing here? We're seeing a negative 5 volts here. We start at 0, negative 5 volts. Okay, we go through V2 here. What are we going to get? We're going to get 0. 0, 0, 0. No voltage drop because no voltage. If I click I, if there's no voltage, there shouldn't be any current, right? Okay, I, 0 amps through the whole thing. So flipping those batteries around basically shuts down the circuit. We've got equal and opposite voltage. So I'll stop this here. Hopefully this makes sense, and we'll continue playing around with these circuits in future labs.